Now we want to prove the converse of Wilson theorem is also true here. Okay, for let's say n is a positive integer satisfying n minus 1 factorial is congruent negative 1 modulo n. Then this n should be a prime number. There is no other way. So let's try to prove it. So let's start with the assumption that n is a composite number, but with this condition, right? So n minus 1 factorial is congruent to negative 1 modulo n. Then since n is a composite, so there must be two integers a and b satisfying n equals a times b. Of course, that two numbers must be between 1 and n and cannot be 1 and cannot be n. And at the same time, because of that, a must be a divisor of n. That's clear. Then from here, a is greater than 1, but n is a divisor of n, and b is also divisor of that, so n cannot be exceed more than n, right? And even cannot be n, so a must be less than n. Then if a is an integer between 1 and n, cannot be 1 and n, then a must be a divisor of n minus 1 factorial, because a must be a certain number like 2, 3, 4, or n minus 1, right? So it must be divisor of the product of all that integers in there. But the condition in this theorem is this one, right? n minus 1 factorial is congruent to negative 1 modulo n. Then by the definition of it, n should be a divisor of this one minus negative 1. So it becomes that, right? But a is a divisor of n, we already checked it, and n is a divisor of this number, which means automatically a must be a divisor of that. We already checked this one before, right? And another fact is, we already checked a is a divisor of n minus 1 factorial. So if we combine these two, if a is n minus 1 factorial, divisor of n minus 1 factorial, and also divisor of n minus 1 factorial plus 1, then a must be a divisor of 1 too, right? But that is a contradiction, because a should be greater than 1, right? So it cannot be a divisor of 1. So this contradiction should come from this assumption that n is composite, because we cannot against with this condition, because that is a given condition for this whole theorem, right? So this is the only part we are assuming, and because we got the contradiction, we have to take the negation of it. So n should be a prime number.